Hi geometry students! Today we will be reviewing and practicing how to determine the area and perimeter of a composite shape. Please use a separate piece of paper to show your work. Remember to draw a diagram of the shape as a reference for the problem. Submit a picture of the paper to Schoology as evidence of your work. Okay, let's begin. First, draw a diagram of this shape including the side lengths. How would you describe the shape? This is a concave decagon because it has 10 sides. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is concave because it has 6 sides that cave in. 1, 2, 3, 4, 5, 6. It also has 3 angles that are greater than 180 degrees. 1, 2, 3. So this is a concave decagon. To find the perimeter of this concave decagon, you need to add all the side lengths together because perimeter is the rim around a shape, the outline of a shape. Since we are missing 2 side lengths, we need to figure out what this side length is and this side length is. First, this side length must be equal to this side length because they are both the short sides of a giant rectangle. So this side length must be 3 centimeters. This side length is part of the long side of the rectangle. Since this is 3 centimeters and this section is 3 centimeters, and this section is 2 centimeters. This missing piece must be 10 minus 2 minus 3 minus 3. So 10 minus 8, which is 2 centimeters. So the perimeter of this concave decagon is 10 plus 3 plus 2 plus 3 plus 2 plus 3 plus 3 plus 6 plus 3 plus 3. Combining like terms, I have 10 plus 4 plus 3, 4, 5, 6, 18 plus 6. So this is 10 plus, combining easy numbers, 10 plus 18. So 20 plus 18, which equals 38. The perimeter of this concave decagon is 38 centimeters. Now let's determine the area. Since this giant triangle is a 3 by 10 rectangle, the area of this rectangle is 30 centimeters squared. This medium-sized rectangle is a 3 by 6 rectangle. So it is 18 centimeters squared. And lastly, this small rectangle is a 2 by 3 rectangle, which makes it a 6 centimeter square rectangle. So the area of this composite concave decagon is 30 centimeters squared plus 6 centimeters squared plus 18 centimeters squared, which is 54 centimeters squared. From the reading, you learned that a point is 0 dimensions because a point can neither go up nor down, nor right or left. Perimeter is 1 dimension, centimeters to the first power, because perimeter measures a line, and a line can go up, down, or left, right. Area is 2 dimensions, centimeters to the second power, because area measures a shape, and a shape can go in 2 directions, up or down, and left or right. So a point is 0 dimensions, 0D. A line is 1 dimension, 1D, and a shape is 2 dimensions, 2D. Let's try the next problem. Draw a diagram of this composite shape, including the side lengths. How would you describe this composite shape? This is a concave hexagon. It is concave because it has 2 sides that cave in and 1 angle that is greater than 180 degrees. And it is a hexagon because it has 6 sides total. First off, this concave hexagon is made up of a triangle and 2 rectangles. In order to find the perimeter of this concave hexagon, you must first find the length of this hypotenuse, this triangle hypotenuse. Since this length is part of the 10 inches less 6 inches, 10 minus 6, this vertical length is 4 inches. Since this length is part of 15 inches less 7 inches and 5 inches, so less 12 inches, 15 minus 12, this length is 3 inches. To find the length of the hypotenuse using the Pythagorean theorem, 3 squared plus 4 squared equals c squared. 9 plus 16 equals c squared. 25 equals c squared. C equals 5. The length of the hypotenuse is 5 inches. So the perimeter of this concave hexagon is 5 plus 7 plus 6 plus 5 plus 10 plus 15. So the perimeter of this concave hexagon is 48 inches. The area of this concave hexagon is the area of the rectangle plus the area of the other rectangle plus the area of the triangle. So the area of the rectangle, which is a 5 by 10 rectangle, is 50 inches squared. The area of this 7 by 4 rectangle is 28 inches squared. And the area of this right triangle is 1/2 base times height, which is half of 12, which is 6 inches squared. So the area of this composite concave hexagon is 50 inches squared plus 28 inches squared plus 6 inches squared, which is 84 inches squared. Let's try the next problem. How would you describe this shape? If you said this was a concave octagon, you are correct. Now find the perimeter of this concave octagon. First off, figure out the length of this side, the length of this side, and the length of this side. This is 17 centimeters because it is the same length as this side. This is 8 centimeters because it is 17 centimeters less 9 centimeters. This length must be found by using the Pythagorean theorem. This length is, again, 8 centimeters because it is the same size as this length. This length right here is 25 centimeters minus 5 centimeters minus 11 centimeters minus 3 centimeters. So this length is 6 centimeters. 25 minus 5 is 20. 20 minus 11 is 9. 11 minus 3 is 6. So the length of this hypotenuse is 6 squared plus 8 squared equals c squared. 36 plus 64 equals c squared. 100 equals c squared. 10 equals c. So this length is 10 centimeters. Now let's try to find the area of this concave octagon. What is this concave octagon composed of? You can see many different compositions, but I saw a rectangle with another rectangle, with another rectangle, with another rectangle, and a triangle. So 4 rectangles and 1 triangle. Figure out the area of this concave octagon by figuring out the area of each. Did you find the area of each shape to be what is written here? If so, then the area of this concave octagon is 313 centimeters squared. To get a 4 on this asynchronous activity, try this problem on your own. I'm going to give you some hints. The circumference of a circle, or the perimeter of a circle, is c equals 2 pi r. Since this is a half circle, what would you have to do? The area of a circle is pi r squared. Again, since this is a half circle, what would you have to do? Although this diagram is not drawn to scale and does not look as beautiful as it should look, pretend that this line is perpendicular to this line and that these segments on either side of the center of the circle is congruent to or is equal to the radius. Okay, good luck.